Good afternoon, Professor. This is my today's personal timetable. In the previous week, I have attended Monday RFI meeting, and this meeting is always scheduled on Monday, and I have also attended biomedical physics class, which is held on Friday. Uh, this class is we have to attend on every Friday. This is Nagendra sir class, and yes, of course, I have studied electronic and telecommunication trends research paper, and I have submitted second assignment of electrical, and submitted MMIC second assignment, and research on radiometer for medical sensing application using two different reference noise source, and also researched on recent radiometer technology, and what I'm going to research in the coming week is saying first we have to attend our RF meeting on Monday, and Friday we have biomedical physics offline class, and next I'm going to study about big data and MMIC course, uh, if there will be any class, so I have to study, and then after that I have to research on the radiometer medical sensing using different noise source, and again I have to research on radiometer technology. So when I have researched about the recent radiometer technology, I have gone through various articles, and I have made this. Uh, uh, the first is the major contribution in this orbit radiometer system calibration has error raised in this from that first it has a uncertainty in cold calibration temperature, uncertainty in warm calibration temperature, and the performance of radiometer transfer functions, any non-linearity and drift, error in ground retrieval algorithm, uncertainty in knowledge of antenna and characteristic. In this cold and warm, these two different noise source addresses that it has three major error source which provide essential cold and warm reference brightness temperature. In this cold noise source, it has a potential to replace the complex and expensive state of practice techniques. As you can see in this, this table is about radiometer calibration accuracy, how it is accurate. Uh, in as first column you can see that there is a cold calibration brightness temperature, second is about warm calibration brightness temperature, third is how radiometer transfer the functions, and the fourth is ground retrieval algorithm, and the last antenna brightness temperature. In first column, cold calibration brightness, it has stability, repeatability, brightness temperature, calibration error, thermal temperature correction error, and residual error. In warm calibration brightness temperature, stability is there, repeatability is there, brightness of temperature calibration is there, thermal temperature correction, and reusability error. Somewhat same you can say in cold calibration, and radio transfer function is non-linearity. It has non-linearity, gain, offset, drift, and bandwidth stability is and quantized error is the duration of calibration, frequency of calibration, and reliability of error. In ground retrieval algorithm, in string retrieval error, second is ocean wind speed error, index of refraction error. In antenna brightness temperature, main near beam efficiency, earth side lobe level, knowledge of side lobe level, and antenna pattern correction APC algorithm. And this is this table is about the system noise temperature, which contribute in two sections, RF amplifier and radiometric system. In this table you can see various columns. uh, One by one I'm going to explain the heading of this column. And first is the receiver configuration. In this, the radiometer, it's about the naming of radiometer and how it is cooled or not. Or a second column is about cooled, which is calculated in unit Kelvin. And the third column is about operating frequency, at which frequency it operates, which is calculated in gigahertz. And bandwidth, fourth column, which is in megahertz unit. And the fifth column is about RF amplifier type and gain, which is calculated in dB. And the sixth is temperature system, calculated in Kelvin unit, and temperature amplifier calculated in Kelvin. And temperature BSS, that is calculated in Kelvin. And T feed, that is calculated in Kelvin. And T second stage remark, and the second last is remarks. And the last column is about reference, from where I have referred this all specific or bandwidth and specific specification of this radiometers. And in this, as you can see, the second row, total power, it has no cooled column has no uh, frequency is about 0.15, and bandwidth is 4, transistor has used 20, and temperature of system was 400, amplifier temperature of amplifier was 200. And uh, temperature feed, it has a 200. Temperature at second stage, it was 1. And remark tunnable over 230 megahertz. And I have referred from AI Bachelor Pro RE in 930s 1969. I have referred this. And in Dick modulation, well, in Dick modulation 1.5, cooled is calculated in 1.9 Kelvin. And the operating frequency is 1.65, and bandwidth is 6.5. And amplifier and gain, which is calculated in dB, uh, that is TW Mars 30. And temperature of system is 37. And amplifier, it has 0. And base of 7. And temperature feed is 20. And second stage temperature is 1. Again, the remark is tunnable over 30 230 megahertz. And I have took the reference from IEEE in 1968. And in this way I have made this comparison table of major contribution in RF amplifier and radiometrics system. After that I have gone through this paper called as a total power radiometer for medical sensor application using match and mismatch or noise source. This was the title of that paper, which is published on Sensor 2017. In this, the abstract of this paper was in this the radiometer total power radiometer has used non-invasive technique to measure the temperature of human body. In this medical application has proposed microwave radiometer using mass and mismatch resistor at room temperature as cold and noise source. Sufficient accuracy for medical application is relatively narrow in input temperature that ranges, and it uses 3 gigahertz radiometer which contain antenna collecting the noise power generated, and in amplifying of noise source power it converts the noise power to voltage via detector. In this radiometer, to design this radiometer, we had used sp3 switch, sp3t switch, single pole triple throw, which is placed in between the antenna and receiver. In it is used to and to process this data. It has used detector output voltage and physical temperature noise source also has been used. In this fabricated radiometer shows a good performance agreement with the radiometer temperature, and measurement of water ranges from 25 degrees Celsius to 43.1 degrees Celsius. Two reference noise source, hot and cold, using match and mismatch resistor at room temperature. Next comes to the introduction part of this paper. In this radiometer had used a non-invasive technique. This radiometer is microwave radiometer to measure the thermal measurement of human body for measuring the core body temperature, to monitor and thermal imaging of breast cancers. And previous in early ages they were using dick radiometer, which has a traditional technique, and it has certain drawback also. um, in you can see it has certain drawback, like it is inexpensive. uh, sorry, it has a it has certain uh, uh, advantages, like it is inexpensive, small sized frontage of radiometer, single reference noise source, and it drawback is it is quite one loaded, calibration is inaccurate. Because of that, noise figure of radiometer does not changes, and it operate at around ranges of temperature 246 to 316, and the performance imbalance among the port in sp3 switch uh, and cause an error in the temperature. Is such error minimized and offset voltage of radiometer output voltage. And you can see in this diagram also, uh, this block diagram uh, has certain partition, like front end, which called as a front end. In front end it has a noise source, antenna, and a dick switch, low noise amplifier, BP, and booster. This way it has a front end, and after that detector to detect all this process, and power meter, LF, PC is connected, to calculate for seeing the temperature, for measuring, and output is after that output will be there. Next, this is the design of radiometer. Two reference noise source, low noise and high gain receiver amplify input noise power generated by an object, and the output of the receiver P out is like G receiver, KB, T in, and T receiver, where T in is K and T receiver is K. An input noise source and equivalent noise source of the receiver. K is Boltzmann constant, it has value 1.38 and 10 raised to 23 GK, and band B is calculated in hertz, is a bandwidth of the receiver, and G is gain receiver gain, you can see. I'm going to explain this diagram in this slide, step by step. Everything I have mentioned in PPT also, and it's easy to understand also. First of all, this radiometer has designed with two reference noise source, and it has a direct conversion receiver. Total power radiometer has a LNA and band pass filter, and detector at output generate voltage is proportional to input noise source power. Output voltage read the DAQ data acquisition board, uh, and it is connected through a personal computer to process all this, and a reference noise source used gain receiver is in this cold and noise source. You can see in this figure also, this in it has reference 1 and reference 2. This is one is of cold and second one is of noise source, and it has used a mismatch at room temperature, and it has been connected through sp3 switch, and after that, they had used along with the antenna and the receiver uh, and the AOB, that is analog output board, switch control the signals, and there are two temperature sensor, and TS1 and TS2, and for noise, this two different noise source, and there is a target T also there, and component and receiver are mounted on single aluminum GI, and you can see in this it has a physical temperature, two reference load TR, antenna TPA, transmission line TPL are equal. Okay, this was the topic in this paper, subtopic, you can say, about the two reference noise source, how it is calculated and what was the equation, uh, some detail about this noise source calculation equations. In this two load calibration is there with different noise temperature, and cold and hot noise source are simply implemented using mismatch resistor of medical application. The resistor at physical temperature provides equivalent noise temperature to receiver with the reference impedance, has equation reference T0 and R reference upon impedance plus uh, receiver reference, and it is based on relation cold and noise source cold and hot noise source. uh, Reference value is 22 ohms, and the reference 2 value is 50 ohms, and reference 1 becomes 0.849, and tr and what temperature reference 2 equal to tr. The equation becomes T reference 1 246 Kelvin, and T reference 2 290 Kelvin at to T reference TR, which is equivalent to this T reference, that is 290 Kelvin. uh, it has I have said this before, T reference and TR is equal, and in this TR is measured by the uh, temperature sensor 1. And yes, again subtopic is about sp3 switch calibration. Some detail about this switch calibration of sp3t. In this input side of receiver, select the ports among two reference load and antenna. Usually amused uh, uh, sp3t switch exhibit the same characteristic in 3 through port, and real sp3t switch can have performance imbalance among the three port, and inaccurate in calibration process, and loss imbalance of switch was considered. Calibration of radiometer, performance imbalance among the port are compensated by adding different offset, and each port generate the same voltage. Each port is terminated with same 50 ohms load. Okay, this is the subtopic about receiver design. You can see in this uh, I have mentioned in this slide two figure. First is the block diagram of direct conversion receiver, and the second is the photograph of this uh, direct conversion receiver, how it look like. And in this figure you can see first in this we had used 3 LNA, which model number is ZX6036 2GL, and mini circuit of gain is of 20 dB, noise figure of 0.9 dB, and 4 bpf is used uh, of 2.4 dB. uh, bpf model was BFCN 3010, and mini circuit has been used. Insert between LNA to limit the bandwidth of the receiver. In this the sp3t switch model number is was SKY 133 4536 8LF, and Sky works. It has a frequency of 3 gigahertz, and this temperature measurement of to measure the human breast or a brain. This radiometric frequency is used. Uh, this topic describes about how the temperature measurement setup has been done, and you can see in this first figure what means how much measurement has been done, what water bath has been used, citrofoam has been used, how much water level was there, everything has been described in first figure. And second is about the photograph, how it looks like in real life. And in this you can as you are aware of this, that it has first in this measurement setup, it has a water bath which is calculated at 0.98, and the figure shows water bath uses citrofoam with dielectric constant 1.03, which is covered settled curtain with 60 dB activation on the top, an aluminium container on the bottom, and a horn antenna is placed just above the water of the surface, about 20 meters centimeter above the surface of the water. And the thermocouple temperature sensors TS1 and TS2 were calibrated using high precious temperature. And this in this during measurement of this, radiometer periodically switches to reference noise source and the antenna by the SP3T switch, and detector for voltage is sampled by the DAQ board, uh, and this all data is stored in PC. You can see the data in personal computer. And sampling was rate as 1 gigahertz. Detector voltage uh, were averaged 250 samples, and determine the receiver gain also gain. Thank you for the day. And this was my personal timetable, today's personal timetable. And I have also shared the what I have researched and what I have learned in this deep about this paper. Every subtopic I have described in this presentation. Thank you.